and when somebody comes, we can accept the person.
Okay, sir. I'm gonna leave them.
Now, everyone, are you there?
Sir?
I'm asking if everyone is ready. Those who are on the group, are you all ready?
Yeah.
Okay.
Yes, sir.
No problem. So we're going to start the discussion and see how best we can do this. So, as you're already aware, we're going to be looking at quadratic function, and a quadratic function is used to draw a quadratic graph. And the quadratic graph is also known as the parabola. So the parabola is what we want to discuss now. Okay. Okay. So let us look at how the parabola is. Now, what's going to happen is that we first have to look at the word parabola. Learners, when you join in the class, you can turn off your microphone. There is a symbol or just a sign there to tell you that is a microphone. You turn it off.
There we go.
Okay. So we have the parabola, okay? Now, this parabola is also known as the quadratic graph, okay? Okay, everybody knows that. If you don't know, then you are knowing it for the first time. That's okay. Okay, and this graph is drawn using the quadratic function. Okay, so for us to draw this graph, remember that the parabola, the shape of a parabola can either be like an N shape and can also be like a U shape. That is the first thing everybody should understand. But remember also that a parabola is drawn using a function. Okay, so this function is in the form of f of x, okay, which is equal to ax squared plus bx plus c. Now, the value of a, the a here in this function does a very important function, or it plays a very important role. And this role is to say that if that a value is greater than 0, it does something. If it is less than 0, it also does another thing. So I'm going to explain to you basically as to what to do. Now, if you look at this, the arrow of this graph, if you look at this graph, you see that the arrows are going towards the negative y direction. They are going down. So it means that they are going towards the negative direction. So if they're going towards the negative direction, then it means the value of a, this very a here, is less than 0. That is why you see a parabola that looks like this. Ntando has just joined us in the lesson. Welcome, Ntando. So now, if you look at the second one, you see that the arrows of the graph are turning towards the upwards direction of the y-axis. So we can say that the value of a here is becoming greater than 0. So we say the values of a are positive. So that is one of the things we need to. So when you are drawing a parabola, it is either turning upwards or turning downwards, looking at the arrows. Now, the C here, it's not always C. Any other person can write W, K, anything, any alphabet here. Now, this C here is called the Y-intercept. So the y coordinate of the y-intercept. What does it mean? It is where the graph cuts the y-axis. We're going to look at that very shortly, so don't worry about that. Okay, so let's take, for example, this function. Let us say we have f of x, okay, is equal to 2x squared, and then we have minus x minus 3. This is our example. So with our example, we have 2x squared minus x minus 3. So the first thing we need to know about this very example, if we want to sketch it, okay? So we are sketching the graph. So let's say sketch, okay? So that everybody will know what we are doing. So if we are sketching this graph here, the first thing we have to consider is the shape. Guys, don't forget, so take note of that. What we need is the shape. How do you consider the shape of a a parabola? The shape of a parabola is determined by the value of a, this very a here. And the a does two things. Either a is less than 0 or a is greater than 0. So if you look at less than 0 means negative, greater than 0 means positive. So look at this value here. This value represents a here. We are supposed to have ax squared. So we have 2x squared. So a here is positive. So if a is positive, it means positive numbers are greater than 0. So it means when we draw this graph, this particular graph, the shape of this graph will be like this, because the y values now are beginning to increase. So the graph will be going towards the upward direction. So that is the first thing you need to remember before we continue. Okay, so the next thing we have to do is to just check the y-intercept, because y-intercept is very easy to find. So we say y-intercept, okay? So y-intercept. Now, usually an intercept is a point on the x-axis if it is x-intercept, and an intercept is a point on the y-axis if it is a y-intercept. So any intercept, if it is x-intercept, then obviously the value of y is 0. If it is y-intercept, then the value of x is 0. Take note. So at y-intercept, we say let which alphabet x be equal to 0. So if it is an x-intercept, then it is y that must be equal to 0. So in this equation now, I can say that, oh, okay, our x is 0. So wherever I see x, I'm supposed to have x in this bracket, but I'll write 0. So whenever I see 2, whenever I see this x here, I'll write 0. I'll raise it to the power of 2 minus 0 minus 3. As you can see, the whole of this becomes 0. That is why we have f of 0 is equal to negative 3. Now, but the shortcut is this. The y-intercept is the c value. Can you see that? So whatever number is representing c is negative 3. So you don't even have to calculate it, but I'm showing you practically as to how to do that. Then the next thing is that when you find x-intercept, you must find y-intercept. When you find y-intercept, you must find x-intercept. So let's look at the x-intercept now. Somebody is just joining the class. Let's admit the person first. It is Sizopila is back. I think something happened and Sizopila dropped earlier. So welcome, Sizopila. Welcome once again, Sizopila. Let's continue. So now we are on the x-intercept. So the x-intercept. Now, the x-intercept, you remember the story already. If it is y-intercept, let x be equal to 0. So if it is x-intercept, you must let which alphabet be equal to 0? Y be equal to 0. So obviously we have this to be equal to 0. But let's write it like this so that everybody will understand. So 2x squared minus x minus 3 is equal to 0. Now, y is supposed to be here, but we have to put 0. But now, everyone knows, You can use two methods, okay? You can use the quadratic formula, or you can use factorization and all that. So if you factorize, which I believe you all know very well, you should be having x, okay, plus 1, and then you have 2x minus 3, which is equal to 0. So if the two brackets are multiplying equal to 0, you will say x plus 1 is equal to 0, or 2x minus 3 is equal to 0. So now x is equal to -1, or x is equal to, the inverse operation of -3 is +3. The inverse operation of multiplication of 2 becomes the division of 2, which obviously you can also write to be a 1,5. Now, if you use the quadratic formula also, you will get x is equal to -1, and the other x is equal to 1,5. So, but remember, this one, look at it, this is the y-intercept. You see, an intercept is a point. So a point is made up of two coordinates. X is 0, y is -3. So you can decide to put it in a point form to say that x is 0 and then y is -3. Nicely. Okay, then here, these are 2 points. So you remember that these are x-intercept. Y is 0. So -1 is to 0. Then the other point will be 1,5 is to 0 for y. Okay, all right. So what we're going to do now, we have x-intercept, we have y-intercept, we have the shape now. What do we need? We need a turning point. So for turning point, you need to first determine the axis of symmetry. Okay, so turning point, okay, turning point. What we need to do at turning point is that we need to find the axis of symmetry first. So axis of symmetry, axis of symmetry. Now, what is axis of symmetry? It is the x coordinate of the turning point. So a turning point has x and y. So what we need to do quickly is to say the formula is x is equal to minus b, okay, minus b over 2a. So now look quickly. So in the formula I have minus, but what is b? What is b here? This is a, this is b, and this is c. So our b is -1. So I'll say -1, okay, over 2 times a. Our a is 2. Now, so minus times minus, or negative times negative is positive. 2 times 2 is 4. So this is the x coordinate of the turning point. So we need to find the y coordinate of the turning point now. So if you have x, come back wherever there is x, you put what? The x value. So the original equation says f of x, but what is x now? Is 1 over 4. So now in the function I say 2 times x, x is 1 over 4, all to the power of 2, the way it is written here, minus 1 over 4, then minus 3. So when you do your substitution into the equation, obviously you are going to get -25, okay, -25 over 8, which can also be a decimal, or a -3, okay, -3, 125, or which we can make 13, is something like that. Okay. Now, but we need to write this properly. What about the 1/4? Somebody is just joining the class. I think Diham Muroka left the class and came back. Okay. So now, remember that this 1/4 can also be written as 0.25 or 0.3. So the turning point, let me just write TP. I'll say the x value now is 0.25, and then the y value is -3.13. So that becomes our turning point. So now we can draw the graph. We have all the elements. Let's see if there is somebody who is joining the class. Okay, no one is there. All right. So now we can draw our graph. Let's see how we can draw our graph. All the points that we found now, we have to enter them onto the graph. So I have to draw the x and y axis first before I know what to do. Now, let me draw the x and y axis. You know that you already have the x-intercept and the y-intercept. You have the turning point, and then you have the shape. So what's going to happen is that we need to draw the x and y axis, the y axis first, okay, and then I can call this one our y, and we can call this one our x axis. Now this x axis, all values of x will be lying on it, and this y axis, all values of y will be lying on it, and then this is also y. Now remember that this is a negative x here, this is a negative y here. Okay, so let's see the x-axis and see what are the biggest values we have. The x-intercept, we have -1, -2, that will be okay. Yeah, because those are the biggest values. So I have -2, -1 here, then I have 1, then I have 2 here. Then on the y-axis, we can see -3 beyond -3. So we can have 1, 2, 3. So -1, -2, -3. Okay. Then 1, 2, 3. So if you are plotting, look at the x-intercept. The x-intercepts are here. So let's look at -1. Remember, it is an x-intercept, so it must be a point on the x-axis. Then this one, 1,5. This is 1. So 1,5 should be between 1 and 2. Okay, it should be between 1 and 2. So this one I can say 1,5 here. Okay. Now, the next thing we need to look for is the y-intercept. The y-intercept is 0:-3. It is a y-intercept, so it must be on the y-axis, so -3 here. Now, the next thing we need is the turning point. So we look for the x value of the turning point. The x value of the turning point is 0,25. Okay, 0,25 is just a little bit away from 0. So let's look for 0,25 here. Okay. Yes. So that is our 0,25 there. Okay, 0,25 is here. Good. Now, what else do we need? We also need, but I'm not supposed to put a point there, but I'm just showing you something. Then I come down to look for a negative 3,13. So negative 3,13 should be somewhere. So this particular one is our TP, our turning point here. Okay, so I will draw the graph, you see, and I will pass through the y-intercept. Then I will go and turn on this turning point. Then I come to the other x-intercept. So basically, the graph must pass through the x-intercept and then go through the turning point and then go through the other x-intercepts. Now, learners, remember, this is a rough sketch. It is not drawn to scale because it is hands that are being used to draw the graph. Okay, so this is how it should have a smooth curve here. Okay, so it's supposed to have a smooth curve. Yes, beautiful. So this is how it's supposed to be like. So learners, this is basically how to draw the parabola. You need to remember one thing, that you need to know the shape of the parabola, whether it is an N shape or a U shape. You need to know the x-intercept. You need to know the parabola in this case has two x-intercepts, though there can be other conditions. But you also need to find the y-intercept, which is easy to find by making x to be equal to 0. You find the turning point. So for the turning point, you need to find the axis of symmetry first. That is x is equal to minus b over 2a. Then you substitute the value. Whatever you get for the axis of symmetry, it is the x value of the turning point. So take it and substitute into the original equation or the original function. Wherever you see x, put the value of x, you will get the y value, which gives you the turning point. So